guys, welcome back for part 2 of chapter 16 notes. This is the slide I'm starting on. It's where we left off in part 1. It's an example of a weak acid, but this time I'm trying to find the pH. So we're basically doing the exact same thing we did in the last example, except there's one extra step. When you find that hydronium concentration, we're going to plug it in the pH formula. Easy peasy. Okay? So, let's see. Here we go. It says I want to find the pH of a 0.2 molar HNO2 solution. All right, so I know I have HNO2. I know it's an acid. It's going to hook up with water. I know when it hooks up with water, it's going to make that. And then I'm going to be left with that. Okay? So that means that Ka is going to be equal to this over that. And I also know from the problem that I gave you the Ka as being 4.6 times 10 to the negative 4. All right, so I go and I make my little table poo-poo that I do, and I have HNO2, H3O plus, NO2 minus, ice. Initial change, equilibrium. And so by looking at the problem, it says that you start with this being 0.2, so that goes there. Those get 0. I lose a little of x. Each of these gain a little. So now I just plug my numbers in over here. So the top is going to be x squared. I know that this x value is going to be tiny, so I don't even put it in there. I just put the 0.2. I multiply those two together, and then I solve for x, and that's what I got for x. So the hydronium concentration is that. Well, I didn't ask you for hydronium concentration. This time I asked you for pH, and I know that pH is negative log H plus or hydronium. I know that that and that are the same thing. So this number is what's going to go in there. And I plug and chug in my calculator, and I got a pH of 2. So all I did this go around was exactly what I did in the first example. But if you are asked for pH, you're going to take this X value, put it in the pH formula, tell me the pH. Super easy for super chemists like you. Okay? Now, we're going to work backwards on the next example. So I'm going to erase all this again. And the next example in your notes, I gave you pH. So you're starting with that number and you're kind of working backwards. Okay? So I have a weak acid. I didn't even tell you what the acid was. I just called it HA. So weak acid, HA, is going to hook up with water. It's going to make some hydronium. It's going to make some of that. Okay? Now, it says that the weak acid's 0.1 has a pH of 4.25. Find the Ka. All right, so Ka equals this over that, right? And I know from my little table that I do every single time. There's my acid. There's my stuff I'm making. Ice. Okay. I know that the acid is 0.1. 0, 0. I know that I'm losing this and gaining that. Okay. It's kind of the same table we have every time, kind of beating a dead horse with it. All right, well, here's the dealy poo-poo. I know that I can find this value for x. And how do I know I can find that? Because I gave you the pH value. I said pH is 4.25. That is equal to the negative log of that. So just like last year when we did these problems, when you have x by log, that's an inverse log. So that goes in your calculator as second log negative 4.25. Okay, anytime that x is by log, that's how your calculator needs it put in. When you put that in your calculator, okay, you should find out that x is equal to 5.6 times 10 to the negative 5. Okay, well, this and this are equal. So 5.6 times 10 to the negative 5 squared over, I would just say 0.1 because I would be lazy. When you get that and plug it in, that is your Ka value. Okay, so that's how you work backwards. Now the next example I want to do with you is finding percent ionization. Okay? And percent ionization is kind of doing the same thing. There's just one little extra thing you do at the end. Okay? Nothing crazy poo. Nothing crazy poo at all. All right, it says find the percent ionization of a 2.5 molar solution of HNO2. All right, HNO2 plus water gives me that. Okay, I know the Ka for this is going to be that. Same thing we've been doing every example. And I told you the Ka value for this is 4.6 times 10 to the negative 4. So at this point, this is where I become lazy. And if you want to become lazy with me, you can too. Everything's being set up the same way. So you should start to see a pattern. So when I do this, sometimes I don't even do that table anymore. I just put x squared over the concentration, 2.5. And I go ahead and solve for x, and that's what I get. That tells me that tells me how much of it has ionized. But when I ask you for percent ionization, you're going to have to take this number over the initial concentration, and because it's a percentage, we multiply by 100. That tells me that only about 1.4% of that solution ionized. Okay, not very much. All right, so that's percent ionization. Now we're going to do strong bases and weak bases the same way we just did strong acids and weak acids. Okay, everything's done exactly the same way. This concludes my chit chat on part 2 of chapter 16. I hope that you found it helpful. Come see me in class if you have questions. Toodles poodles.